All right, so in this example, we have three wave patterns that we're going to look at. In the first case, we have a 4-meter amplitude wave approaching a 2-meter amplitude wave, and they're both on the same side, traveling towards one another. In the second case, we have a 3-meter amplitude wave about to collide with an 8-meter amplitude wave. However, the 8-meter is below the equilibrium point and the 3 meters is above. And in the last case, we're not going to look at it mathematically, we're going to look at qualitatively. We're going to imagine, it's not realistic, we're going to imagine this square blocky wave and then kind of this round wave. And if they were to interfere on opposite sides, what would that look like? So we won't apply values to the last question, but we will certainly try and figure out what the shape of it looks like. So in the first case, we realize we have a 4-meter wave, or 4-meter amplitude wave, and a 2-meter amplitude wave, and they're both on the same side. So when those two collide, hopefully you recognize that's constructive interference. In the second and third cases, we're going to have the opposite. We're going to have destructive interference. But for the constructive interference, we're going to add those amplitudes together, and for a brief moment, you will get a wave that has an amplitude of 6 meters. And then if we kind of play that forward in time, the 2 and the 4 will pass through one another. So you'll notice the 2-meter was originally on the right. After the interference, it's on the left. So they will not bounce off. The 2 won't turn around and go in the other direction. It's going to continue to travel in the same direction it was traveling through. They will pass through. But that brief moment in the middle, you will see a 6-meter amplitude wave. In the second case, I've got 3 meters above, 8 meters below. They will destructively interfere, so I will subtract those. And I'll wind up with a 5-meter amplitude wave that's below the equilibrium point. Once again, when we allow time to continue forward, the 8-meter will continue traveling to the left, the 3-meter wave will continue traveling to the right. They do not bounce off one another, they pass through. And in the last case, there's no math to do, but the square wave is trying to pull everything up. The circular wave is trying to pull everything down. So that means we want to take the circular wave above and we want to subtract the square wave above, and we want to subtract that circular wave below. And if we do that, we get this interesting pattern. You're basically taking that kind of half semicircular wave, and you're just biting that piece out of the square wave that was above. And then a split second later, the square wave will continue traveling to the right, the circular wave will continue traveling to the left, and the interference will have occurred and be done.